What is current? Current is the rate at which charge is flowing. Okay. It is the rate at which what is flowing? Charge is flowing. Okay. And it is measured in amperes. In fact, let me tell you, amperes is the SI unit of current. And it is denoted by capital A. Okay. Now, in a metallic conductor, the flow of current is due to the flow of free electrons. Okay. Now, inside that conductor, even positively charged particles are there, which tries to block or obstruct the flow of electrons. Okay. So, the material's tendency to resist the flow of charge is known as resistance, and it is denoted by capital R, and its symbol, you can see the zigzag line. Okay. SI unit is ohm. Okay. And see how it is written. Okay. Then you can see here battery. Now always remember, in a battery, the longer line stands for positive charge, then shorter one negative. Positive, negative. Okay. A battery is a combination of cell, which provides the potential difference. Now, what did I tell you? I told you that electric current is due to the flow of electrons, right? So they should follow from the negative charge to the positive charge. But you can see the signs are just the opposite. Okay. So why is it opposite? It is opposite because conventionally, what do we follow? We follow the flow of electrons is from the negative to positive. Okay. But the flow of electric current is from the positive terminal to the negative terminal. Now, so what is it? Electric current, it is the amount of charge flowing through the cross section of a conductor. Okay, cross section of a conductor. Now you know what is the cross section of a wire. No, it's a circle in 1 second. So if we denote charge by Q, time by T, and current by I, what we can write? I is equal to Q divided by T. Now, we can also write Q is equal to N into E. Why? Because N is the number of electrons and E is the charge of an electron. Okay? And 1 ampere is equal to 1 coulomb, which is the work done in 1 second. Okay? Now we'll come to a very important term, potential, the amount of work. Now, what kind of work done? Per unit charge. Okay. So it is the amount of work done per unit charge in bringing a positive test charge from infinity to that point. Okay. So you can see the diagram out here. So plus Q is the charge. Okay. Can you see plus Q? Yes. So what is potential? It is the work done in moving the charge plus Q from infinity, as you all can see here, to the potential P. Okay. At the point P. So you can see the charge, right? Now, what is the charge? The charge is Q. Okay. It is Q. It is Q. Then what do we see? The charge Q is moved from infinity to the point P. Okay. And the amount of work done, suppose W is the amount of work done in bringing the test charge plus Q from infinity to the point P. Then what we can write? We can write that electric potential at the point P. Okay. So what is that? Electric potential at the point P It is equal to P by Q. Okay, it is equal to Q by V. Okay, now let's see what is potential. It is the amount of work done per unit charge in bringing a positive test charge. So this is the positive test charge, okay? From infinity to that point in the presence of positively charged body. So if W is the joule of work done in bringing the test charge Q, okay, from infinity to the point P. Now, what does infinity means? Infinity means it does not have any limit. So, what will be the electric potential V at the point P? It will be equal to W by Q. Okay. So, what will be the SI unit of potential? It will be equal to unit of work, which is joule, divided by unit of charge, which is coulomb. Okay. So, that it will be joule per coulomb, as you can see here. Okay. Then next, let us move to potential difference. Now, they are not the same, okay? Potential and potential difference. Now, whenever the word potential difference comes, no, you always must keep one thing in mind. It is the work done in moving a per unit charge, okay? But how? Between 2 points, okay? For example, A and B are the 2 points. So, potential difference is the work done in moving a per unit charge from one point to the other point. Okay. So, what we can write? VA minus VV is equal to W by Q. Okay. But the units of potential and potential difference, they are same. So, what we can write? V is equal to joule by coulomb. Okay. Now here you see, we are going to study about the resistor. Okay. Now, what is a resistor? It is an electronic component that limits current. That means which tries to stop the flow of current. Okay. They cannot generate power. But what do? They consume power. Okay. They also have a fixed value of resistance that they can provide. Example, here you can see 1 kilo ohm. Here 47 kilo ohm. Okay. Now, we are going to study about the circuits. Okay. There are 2 different kinds of circuit. One is series circuit, where only one path is there for the current to flow. Here you see, it is the same path, R1, R2, and R3. Okay. Parallel circuit, which has multiple paths. You see, the paths are different. Okay. As you can see, R1, here R1, R2, and R3. So they are different paths, okay, that can move simultaneously at the same point. Now, in a series circuit, what we can say is that, okay, if we need to calculate the total resistance, also known as the equivalent resistance, what we have to do? We have to add R1 plus R2 plus R3 because they are connected in the same circuit, in the same path. But for parallel circuits, okay, which are connected in parallel, different paths, How do we calculate the equivalent resistance? It will be the reciprocal of the equivalent resistance will be equal to the sum of the reciprocal of the individual resistances. Okay. Now, we are going to study Ohm's law. Now, what does Ohm's law say? Ohm's law says that the electric current, okay, passing through a metallic conductor is directly proportional to the potential difference. Directly proportional means if the electric current increases, or we can say if the potential difference increases, electric current will also increase. But the condition is temperature remains constant. Okay. So mathematically, what we can write? I is proportional to V, or we may also write V is proportional to I. R is a constant. Okay. Now here you see Ohm's law triangle. Okay. So the triangle is divided into three parts. Voltage is in the upper part. In the lower base, you have current and resistance. So voltage will be equal to I into R. Okay. Now, if you need to calculate I, it will be V divided by R. Okay. And if you need to calculate R, it will be V divided by I, as you can see here. And let us see the graph. If you take voltage along the x-axis and the electric current along the y-axis, what do we get? We get a straight line passing to the horizon. Okay. Now we'll see one application of one numerical. So this is a circuit, right? Current is how much? 3 ampere. Resistance is 2 ampere. We need to calculate the voltage. So V is equal to I into R, right? So 3 into 2 is 6V. Now we are going to solve one problem as well. Now you see. Okay. An electric gadget draws a current of 200 milliampere from a battery of 12 volt. Find its resistance. Now, while doing numericals, first thing is that you must write what is already given here in the numerical. So, what is given? Current is given. What is the value of current? It is equal to 200 milliampere. Okay. Now, you convert it into ampere. So what is the formula for converting into ampere? 1 milliampere is equal to 10 to the power minus 3 ampere. So what we'll do, we'll multiply. Okay. 200 into 10 to the power minus 3 ampere. So what do we get? 200 divided by how many zeros? 3. 1, 2, and 3. 0, 0, 0, 0 cancel. So what do we get? 0.2 ampere. Okay. And what is the voltage? The value of voltage is given. It's equal to 12 volt. 12 volt. So what formula are we going to use? Always remember V is equal to I into R. So R will be V divided by I. So what is the value of V? 12. And here what do we get? 0.2. Okay. Or we can write 2 by 10. So which is equal to 12 into 10 by 2. So what do we get? We get 60. Okay. Now you can write a unit. What is the unit of resistance? It is ohm. Okay.